they'll be able to watch it later. So just quickly, in 2 weeks we have our last, I think it's 2 weeks from now, we have our last scheduled BPI auditor class. I think we have 4 people we're expecting to attend that, and Wade has been in communication with those 4 people. So as a reminder to those guys, if you haven't got your stuff done, get it done this week or whenever Wade said it needs to be done. And if you have any issues or questions, get in touch with Wade today and work them out. And then coordinators and anybody else on the line, if you feel like you need that class, speak with your coordinators, and coordinators, if you'll reach out to us, we'll work with you to schedule any other needs on that. Also, I mentioned this last month. If you need your lead training, the state, we do not provide lead training. We found that the U of U School of Medicine does a really good job, offers all that training, and so that has been the go-to for everybody in the state. If you've tried to find other trainings out of state, they're extremely expensive, and I haven't actually found a good resource that offers everything the U of U stuff does. So if you need the lead, make sure that you're looking at their schedule. They released their schedule last month. Most of the lead trainer, and there's another one that they land right in January, February. So now that their course schedule is out, you need to get on there and get scheduled right away. Be aware that if you're doing a refresher course, you have to do that refresher course every 3 years. And there was an issue where if you don't make it within the 3-year window, you have to retake one of the tests, which may or may not be difficult for you. I hear that it's not simple. So if your stuff doesn't expire till next year, you may consider doing your refresher this year, because basically it could expire the day before next year's class, and you won't be able to control that at all. So anyway, if you need it, just there's the link there, and go there, get scheduled. I get the pleasure of taking the lead trainer. I can't hardly wait. So I may see some of you in that class. And then the other thing was, just in last month's meeting, I was not able to upload a video during the meeting so that you guys could watch it, so I posted the link. The guys up in Logan helped us out, showed us how they're doing a closed blow on some insulation. So if you haven't seen that, you can just search the Utah Weatherization YouTube channel, and you should be able to find that, or there's the exact link there if you want it. Any other questions on old business items? All right. The only new business item that I have listed is just a reminder for coordinators that we've got coordinator meeting next week in Richfield. Hope to see you all there. Does anybody else have any other items that they wanted to talk about or address or suggest before we move on to the main topic? I'm hearing nothing. So Wade, are you on the line, and are you ready for me to switch over to let you be the person in charge?
Yes, sir.
If I can figure out how to do that.
You can figure out how to do it, and I can figure out how to do it. We'll be in good shape.
It would be nice. The part of my screen that normally lets me do that is hiding. Give me just a second.
Yep, no worries.
There it is. I'm assuming you're the Wade Thompson in the list. So if you're
Nope.
not, let me know in a minute.
All right. Can you guys hear me?
Yes, sir.
Can you see my screen? Can you see my screen?
Yes, sir. Yep.
Yes. You see my little pointer moving around in a circle?
Here and else and stuff.
Yes.
Lavender's good.
Okay, let me see if I can get a PowerPoint up and get it going here. Alright, you guys see the PowerPoint?
Yep.
Hold on. What did I do?
Yes.
Okay, so I've been asked by Matt Turner and by a few auditors now to provide some guidance and training on how to identify PSC motors and ECM motors. And so for the purpose of this presentation, we'll be referring just to the types of blower motors that we find in furnaces, because those are the ones that you're mostly dealing with as auditors. And so the two different types that you're going to run into, the only two types you're going to run into, are PSC motors, which stands for permanent split capacitor, and that'll make sense to you why they call it that once we get through this presentation. And then the other one you might run into is called a ECM, or electronically commutated motor, and we'll talk a little bit about the differences between those two. Bear in mind, guys, this class is strictly for motor identification. We're not going to get into service or installation. Those are more technical classes. So again, we're just going to go over some quick and easy ways you guys can determine what type of motor is in a furnace, because as auditors, you're evaluating some of the motors for replacement. Does that make sense to everybody? Are you all still there?
Yep.
Okay. All right. So PSC motor, permanent split capacitance motor, or permanent split capacitor, first and foremost will always have a remote capacitor attached to it. So that's this little guy over here. And there'll always be two leads. They're typically brown and white, but you will find them in other colors. I've seen them in purple and I've seen them in blue. But most commonly there'll be a brown and white lead that runs to some sort of remote capacitor, thus the name permanent split capacitor motor. It's the most common motor that you'll find in furnaces, especially the older furnaces that we deal with. And the other attribute of a PSC motor is it will always have multiple speed leads. So you can see here we've got high, medium, and low, and then a common. And those multiple speed leads will always attach to speed pins on a circuit board, and the speed pins will always be marked low, medium, high, or heat, cool, park, so on and so forth. So in this case we have 3 speed leads, a common, and our 2 capacitor leads. That's the quickest way to really identify these. If there's a capacitor with it, it's a permanent split capacitor motor and could be evaluated to be replaced with an ECM. So here I've got a picture of a PSC motor. Again, you can see all the leads coming out. We've got the capacitor over here. I've got some better pictures of a capacitor coming up. But again, 2 wires always going to the capacitor, in this case brown and white. We have 4 speed leads, black, red, yellow, blue, and then our common lead, and then you'll also have a ground somewhere. Okay. And so these speeds are typically black is low, red is high, yellow is medium low, blue is medium high, and then our common. Okay, so that's one quick way to determine what type of motor you got. Does it have a capacitor, and what are the speed leads doing? Okay, I mentioned the speed leads will always connect to pins on the circuit board. So here you can see we have our blue, yellow, black, and red wires. In this case, the board, rather than being marked low, medium, and high, and so forth, is cool, heat, park, and park. The park terminals are just bonus terminals that do nothing. So in this case, this furnace is using 2 of the 4 available speeds. So red on cool, which would be the high speed lead, black on heat, which would be the low speed, and we have 2 bonus speed leads. If we wanted to pull the red off and put it on park and move this one over here, we could change the speed for cooling, or same with heating. You can swap these leads around to change what speed the motor runs on when it sees a signal from one of these 2 terminals. So again, the ones that say park, they're just dead terminals, just somewhere to put these 2 wires so they don't hang out there in the breeze and short out on something. Okay. The other thing about PSC motors is they all, every single one of them, have cooling vents on the end of the motor. So you can reach your hand right into the motor, and if you fill these holes on the end of the motor, they'll be both on the back and the front. Those are cooling vents. That allows air to get in and cool the motor, because PSC motors by nature produce a ton of heat. It's part of what makes them so inefficient. Just so you know, these holes, when they get plugged full of dirt and crap, it actually affects the performance of the motor, because now you're eliminating its ability to cool itself, and it will start to overheat, and it will become more inefficient. Eventually they can overheat to the point where they've ruined themselves. And again, here's a good picture of a capacitor. Okay, capacitors can be oval shaped or round, and again, we have two wires. There'll always be two wires on a PSC motor that go to some remote capacitor. So if it's got a remote capacitor, the multiple speed leads that go to individual pins, and cooling vents, you can guarantee it's a PSC motor, or a permanent split capacitor motor. Okay? Any questions so far on PSCs before I talk about ECMs and the differences on ECMs?
The only question I have is the solid brown wire normally goes to the Herm side on the capacitor, correct?
Well, now you're talking compressors. Okay, so if you have a capacitor that has a Herm marking on it, that is a capacitor for a compressor. You typically won't find Herm. Well, I take that back. On condensers, they have a multiple capacitor, which has common Herm and fan. Okay, so again, we're just talking about blower motors for furnaces. But yes, on a condenser, you'll have a capacitor with 3 terminals on it, and there'll be common Herm and fan. And
I see them on evaporative coolers all the time. That's just standard motor, right? Standard PSC motor?
Mm-hmm.
Okay.
Yep. I haven't seen a 3-prong capacitor on an evaporative cooler, but that doesn't mean they're not out there.
Yeah, but who knows what they replace them with, so maybe that's what it
Well, yeah, and that's true. Someone could have just had something in their van to replace it with. So. And again, for this presentation, we're talking strictly furnace blower motors. So yes, there are other motors out there for other applications, but we're just talking about furnace blower motors here.
Guess it depends, as long as the farads add up anyway.
Yep. All right, so we're going to go ahead and talk about ECMs a little bit. So one of the key points on an ECM motor is they're always going to have, with few exceptions, and we'll talk about the exceptions, they're going to have this big old 16-pin connector. And some of the older ones might only be a 12-pin connector, but they're always going to have this great big 16 or 12-pin connector, followed by another 5 or 4-pin connector. And they're going to use these Molex plugs. There's 16 pins on there, 5 on that one. That is the most common ECM, factory installed ECM setup you'll see. We'll talk a little bit about retrofit aftermarket ECMs towards the end. But factory installed ECM motors are going to have these 2 big old Molex plugs. This one will always be 16 or 12 pin. This will always be 4 or 5 pin. The other thing is ECM motors have no capacitor. There will be no remote capacitor associated with this motor. Okay? That's a dead giveaway. If there's not 2 wires running from the motor to the capacitor, it's not a PSC motor. It's more than likely an ECM. Here I've just got a close-up of an ECM motor in a furnace, and again we're seeing the 16-pin Molex connector. Notice that not every pin has a wire in it. Some will have a wire in every pin, some will not. Okay, that's normal, but the key thing here is we got these 2 big Molex connectors plugged into the side of the motor. Pretty dead giveaway that you're dealing with an ECM motor. Okay. The other thing is on factory installed ECMs, that Molex plug, all of the wires will always go to another Molex plug on the board, and it'll be marked. It says motor connector or motor or something like that. They sometimes call it circulator. So you'll have a 16 or 12 pin Molex, and you trace those wires back, they will always go to a corresponding 16 or 12 pin Molex connector hooked right on the board, and it will always be marked. Okay. Another dead giveaway is if the board has a CFM light. ECM motors will always have this CFM indicator. Some older ones you'll see a separate circuit board called the fan or circulator circuit board, but it'll still have this CFM light. This light actually flashes one time for every 100 CFM that that fan is delivering. So if you ever wonder, I wonder how much air that's moving, if you count that light, how many times it flashes, one time for every 100 CFM. So if you're seeing stuff like that in the furnace, pretty dead giveaway that you're dealing with an ECM rather than a PSC. Here's the other thing is ECM motors are comprised of two parts. Over here we have the actual motor. Okay, this is where the stator and the rotor and all that stuff is located. And the back of the motor, this is called the module. And you can see our 16-pin connector here. On the other side of that is the 5-pin connector. This is what converts AC current to DC current and causes this thing to work and spin. And you'll notice we're looking at this from the inside, but there's no cooling holes in the back of this. And next I'll show you a picture from the other side. But the module is always bolted or clamped right to the back of the motor. Okay? And you can see on this motor here, our cooling holes are up here on the side, there and there. So because of the construction of an ECM, two components, the motor and the module, ECM motors don't have cooling vents on the end of the motor. So they'll be just flat. You can reach in the furnace, rub your hand across it. If there's no cooling holes in it, it's not a PSC motor. PSC motors in furnaces always, without exception, have cooling vents in the back and the front. ECM motors do not. Okay? And again, it's just because of that design, because we have a module that controls the conversion of electricity from AC to DC, and it mounts to the back of the motor. And now this motor has cooling holes on the side. And ECM motors don't produce nearly as much heat as PSC motors, so they don't need all that extra cooling anyway. It's part of what makes them better motors and more efficient. So now we have this. This is called the Evergreen Retrofit ECM motor. So far up to this point, everything I've been referring to has been factory installed ECMs, so they're installed by the factory in the furnace before it goes out. But it's possible you run into these. These are what you're evaluating to replace should you evaluate a furnace with a PSC motor. So your HVAC guys are installing this motor. This is the motor that we're going to put in place of a PSC motor. It's called the Evergreen Retrofit ECM. The thing that's cool about these is, as a service tech, I can carry two of these motors with me, and having two of these motors with me, I could replace every possible PSC motor I might run into, with very few exceptions. And those exceptions are just physical mounting points. But like this motor here will replace all these different size PSC motors. Then they make another one that goes from 1/2 up to 1 horse. They're multi-voltage. They can run off 220 or 110. One key thing about them is they're always green. So if you see a green motor, it's probably an evergreen. These are only suitable for replacing PSC motors, existing PSC motors. These are absolutely not compatible with nor suitable for replacing a factory installed ECM motor. They will not work with a factory ECM setup. They're only for replacing existing PSC motors. Okay? Critical that you know that. Now these guys, instead of having a big 16-pin Molex, they're going to have a 5-pin Molex here and a 4-pin there. Okay? But again, notice the connectors here on the side of the motor. It's a big, nice, juicy Molex connector. These kits may come with a connector, a solid connector, or individual leads. Okay? Also, there's no capacitor associated with these again, and they're green. If it's a green motor, every one of these evergreens are green in color. Okay? The module is right here, so you can actually undo these screws and pull that module right off of the motor if you were so inclined. Also notice no cooling vents. Okay? The back is solid because of the construction. This is a module here with all the electronics in it. Cooling vents are up here on the side. If any of you want to take the initiative to learn more about motors, this website right here that's stamped on every Gentech Evergreen motor is an awesome website. I use it all the time. It's got a lot of information about motors, both PSC, ECMs, what's coming up in the industry, all that kind of stuff, troubleshooting guides, schematics, hell, you name it. They've even got a 1-800 number you can call if you're having a problem with a motor, and they'll help you right on the phone. So really good website for anyone who's wanting to take the initiative to learn more about motors. Good stuff there. And just to talk a little bit about the major performance differences between a PSC and an ECM. So PSC motors are 60% electrically efficient, and they produce a lot of heat. So 60% of the energy they use is used for work, for turning the motor, and 40% is converted to heat. That's why they have all those cooling holes in them. They make a lot of heat. Okay? And that's 60% at best. Some are way less than that. ECM motors are 80% and up efficient. They don't produce nearly as much heat. They're better at converting electrical energy into work. So that's what makes them way more efficient and better motors. One thing that you need to know is as static pressure goes up, and hopefully you all understand static pressure. We've talked about it a little bit, at least you've heard the term. But as static pressure in a system goes up, PSC motors actually move less air. In the industry, we call it they get lazy. If static pressure goes up, the PSC motor gets lazy and it moves less air. That starts to screw up your efficiencies, especially with air conditioning. It starts to cause problems, temperature rises on your furnace. ECM motors, airflow remains consistent or constant. They're also known as constant torque motors. And the way an ECM does that is it ramps itself up. It draws more amps. It increases its torque as static pressure goes up. And that's why we have to be very, very careful when we're installing ECM motors, because as static pressure goes up, a PSC motor will actually draw less amps, okay? But an ECM motor will draw higher amps because we've told it. You tell the ECM motor, hey, I want 800 CFM, it'll go, okay, I'll give you 800 CFM no matter what. So I've actually seen instances in our program where someone took out a PSC motor that was running at maybe 2 amps, put in an ECM motor, but because static pressure was so high, now the ECM motor was drawing 6 amps or 8 amps. And the math is real easy. Amps times volts equals watts. I mean, it's 3 times as much if you've got high static pressure. So in some instances, we did the customer a horrible disservice because we didn't check static pressure. You should never be installing an ECM motor in a system with static pressure over 9 inches of water column.
We learned that the hard way already once. We blew ahead on one.
Yeah, you're asking for trouble. They will go bad. And my personal opinion, this is my personal opinion, if your static pressure is over 0.8 inches of water column, I wouldn't put an ECM in. I would figure out what's wrong with your static pressure if that's the route you want to go. You'll find on almost all mobile homes, static pressure is high in those systems because they're just crappy duct systems. Mobile homes are not necessarily good candidates for ECM retrofit motors. If you're going to do that, be sure you're checking static pressure. Okay. ECM
There's a reason they don't factory sell them like that, though.
That's right. ECM motors are great motors. They are more efficient. They will improve a system. They can fix a lot of problems, but you got to keep this little tidbit in mind right here. If your static pressure is over 0.9 inches, an ECM motor is a horrible choice. It will not fix the system, and it will cause you callbacks and problems you don't want to deal with. Okay? Some of you already know that. And that's all I got for you guys. Do you guys have any questions, comments, or anything?
Yeah, I just wanted to add something. Typically, ECM motors have such a high payback. You can add like a media filter box or extra ductwork if you have the availability to install it to reduce your static pressure. So
Absolutely.
All that cost can be added to the SIR of the motor itself.
Absolutely. Yeah, that's great. You can, roll that into your cost if you can figure out what's your static pressure problem and what we might do to fix it. Quite honestly, guys, most of the time fixing static pressure is just the ability to add more return air. That's just a rule of thumb, okay? Generally speaking, it's been my experience, the industry's experience, that most static pressure problems are in the return. That being said, will you find static pressure problems in supply? Absolutely. I've seen that plenty of times too. But the return system is a good place to start. Okay?
Is that normally because they, when people build a house, they don't put returns in basements, but they'll add deliveries or unfinished basements? Is that normally the reason?
That's one reason why, because most homes are built with a lack of return air. They figure, oh, one return in the hallway upstairs in the house is enough. It's not. It's really not. Another thing we see that in our program that causes high static is the trail houses or the hoarder houses. So there's 10 vents in the house and 9 of them are covered with crap. That'll create high static. Same with the returns. So you got a house with 3 returns in it and all 3 of them are piled up with whatever our clients pile up in their houses. If you see those types of houses, you know, they'll probably have high static because...
Yeah, we tell them the more stuff they put on the vents, the better it is for their house.
Yeah. So those are things to keep in mind. I'm happy to make this PowerPoint available to all of you, so if you need to go back to it and go, oh, I can't remember what he said, well, you know, how do I determine what this motor is? Happy to send it all out to you so you've got it. Again, this is just...
I'll post this video on the YouTube channel as well.
Oh, perfect.
I'll share the whole meeting with everybody, but I'll cut out the first few minutes and post this as just a ECM training.
Okay, perfect.
I got a question for you, Wade, and I hope this is not too far off topic, but it's the question I posed to you last week about all electric. You know, we have electric air furnace. When is an ECM motor a good option on an electric furnace? Or is it?
And it can be converted to gas.
An ECM motor is a good option on any air handler that has a PSC motor, so even an electric furnace. Okay, so the electric furnace has electric strip heat in it that produces the heat, which, by the way, if you guys didn't know, electric resistance heat is 100% efficient. Everything you put in it is exactly what you get out of it in heat. So the industry says electric heat is 100% efficient. The problem is electricity costs so much more than gas. But anyway, yes, an electric furnace that has an existing PSC motor in it.
That's a whole other subject to argue about.
An ECM will improve the airflow. Assuming static pressure is not too high, it will reduce the overall electrical consumption on that furnace because now you're changing the amp draw. And this is a really common example. So I have a PSC motor in an air handler running at 4 amps. We put in an ECM and the static pressure is not out of this world. And the ECM motor will draw an amp or less. So we've really made a significant reduction in their wattage consumed by that motor. Will the ECM motor change anything on the resistance heat side? No, it's not going to reduce the amp draw on those electric heating elements. It will give better airflow, creates better efficiency because we're moving more of the heat into the space, that type of thing. But yeah, anytime there's a PSC motor in any air handler, it's worth evaluating for an ECM, but always make sure that someone, if it's not you, someone is double checking static pressure, because if it's over 0.9 inches of water column, you're doing the customer a horrible disservice, and I guarantee you'll get a call back.
Gotcha. Yeah, thank you for that. So by putting an ECM motor into an electric forced furnace with the heat strip, it could actually save the client some money.
Yes.
Even though technically it's 100% efficient, the efficiency we're talking about the heat strip, not the delivery.
Yeah, we're talking 2 different systems there. So the heating elements, the part that makes the heat, yes, they're 100% efficient because every watt you put in them, you get 1 watt out in heat energy. But the motor is the second part of that system. And a PSC motor, as I mentioned, is only 60% efficient at best, at very best. So putting in the ECM motor will save them money on the air movement side, but it's not going to change anything on the electric resistance heat side. Does that make sense?
Yeah. I would imagine as if you guys run into that, auditors specifically, if you run into that, you'll probably have some questions about how in the world to show an SIR on that, and when you do run into it, reach out to me and let's work through it. So, if that is the route that you end up going, When you're done, Wade, I don't know if there were other questions, but I just wanted to review. I wanted to take a minute and review what's in the guidelines and why the auditors need to know about this. So.
Yeah, I got a question. I got a couple questions.
Go ahead.
Oh, so at how old should we not be looking at putting them in? 10 years, 12 years, 8 years? You know, as far as payback, if, you know, in our audit, you know, the furnace, we're only looking at keeping a furnace for 15.
That's a good question. What do you think, Wade?
So let me make sure I understand you right. You've got a furnace that's 15 years old, for example. Should I evaluate that for an ECM or not? Is that your question?
Yeah, something like that, or 12 years old. You know, we're expecting it to have a 3-year span, you know, lifespan left.
Yeah, I would probably, you know, we could go to our guidelines and maybe get some guidance if you're going to spend, and I can't remember exactly what the numbers are, but I think it's like $300. If you're going to spend more than $300 on that furnace, you're probably better off looking at just evaluating it for replacement.
Yeah, and that's the 10-year mark.
Yeah, if I've got a furnace that's that old, I mean, the one question I'm going to ask myself is, what is it costing me to put this ECM motor in it, and is it worth it? Or, you know, if that furnace is only going to last another few years, is it worth putting that motor in? Probably not.
Chances are you'll be back there replacing it when it does go out.
Yeah, exactly. So that's what I would look at. I mean, if you're talking 12 years and older, just ask yourself that question. What kind of shape is this furnace in? What kind of furnace is it? You know, now a lot of the builder's grade stuff after 12 years, they just start having issues. And really, in my opinion, putting an ECM motor, a nice motor in a furnace like that really isn't worth it. I would be looking at evaluating it for replacement. That's my input on it. That being said, let's say you got a furnace that's 12 years old and it's in great shape, and you figure, heck, if the client takes care of this, they can get another 10 years out of it. Is the ECM motor worth it? Sure, it'll save them money, okay? Assuming static pressure is good. But most of the stuff you guys run into out there, if it's that old, I'd be looking at a way to replace it and not spend any money on it. Because like Lauren said, you'll probably be back in a few years.
Yeah, thanks for that, Tony. That's an excellent point, that you definitely want to take into consideration the age of the equipment and its expected lifespan.
So
Are there other questions?
the next question is, in the guidelines, you know, when they evaluate for the ECM motors, it's only evaluating for the heat season. What about the cooling season?
That's a good question. I don't know. Are you talking about, where in the guidelines are you talking about? Are you talking about in the audit section?
The audit guidelines.
All right, let me get there.
Yeah, during the heating season, if you can get it to give an SIR of 1, though, you're still in good shape.
Oh yeah, and it'll save across the board. I mean, if you're saving them in heating, you're sure as hell saving them in cooling. If they got AC on it and you put in an ECM motor, absolutely, the savings is across the board through both of the seasons. And not only that, that ECM motor, if it's done right and all the airflow is good, it actually improves the efficiency of their air conditioner. Air conditioning is all about airflow, guys.
But that's where you got to be a little more careful with static pressure, because when you get into the cooling, it'll actually raise it a little bit.
Yeah, exactly. You got to make sure you're checking both sides of that, because in cooling, that fan's going to run at a higher speed, which means more airflow, and more airflow means potentially higher static. So again, that's the caveat with these motors. You've got to understand static pressure and what you're getting yourself into when you're putting them in. But yeah, absolutely. If you're saving them money, if you got an SIR of 1 and you evaluate it on the heating side, guarantee you're saving them money and making their air conditioner more efficient if it's done right.
So Tony, were you asking, like, can you include the savings that you would get from the air conditioning side of things to show the payback?
Yeah, we know it's going to save. It's just not in there. It's not
right, and I think the calculator too, it only has you input the heating degree days. It does not have you input the cooling degree days.
Okay. Would that help? Like, do you want the calculator to let you do more ECMs, or would you prefer to have it stay just looking at heating degree days. Like
on the website, it has both.
I think the bigger question is how close to a 1.0 or a 0.9 or a 0.8 SIR are we getting to where we would need to add it?
Yeah, I'd say at this point, I think it's a fair question. As you guys run into it, loop me in on what's going on, and we can look at the next few of them and kind of decide. Like if you're running into it where it's just barely not paying back, and we really want it to, we could look at that. But at the same time, is this ever putting us in a situation where like we're really close to just being able to replace the whole furnace anyway?
Right, but that's the problem. It always pays back.
And are we voiding the warranty of like a newer furnace when we put in one of these?
That's something else we need to consider. I would imagine you probably are in most cases. So
if we haven't been doing it because of that, I mean, you want us to document everything. Is that how we're supposed to be documenting it?
yeah, just make a note. Like so from the audit side of things, I have on my little checklist, I just have a thing that says, did you evaluate for an ECM? And the evaluation is all of this. It's, you know, I looked at the equipment and I thought about it, and we realized, no, the effective age of this equipment made this not a good candidate, or this equipment was, it was 2 years old, it was still under warranty, and we didn't want to void the warranty. Just some indication in your notes that you guys are thinking about this and that you're not, you know, that I want to see that we're actually considering this.
So do you want us to consider them for mobile homes too?
Well, and like Wade was talking about, so if on a mobile home, yes. I would say yes for now. If we find that 99% of the time the static pressure is not within range, then, you know, once we have that little pile of data, then we can just say, you know what, we'll just put something in the guidelines to stop wasting our time.
I speculate that on mobile homes, you guys will find that's the case. 90% or higher of the time, the static pressure is going to be too high, and there's not a lot you can do to fix it, or at least not a lot you can do that's cost effective or even worth your time to bother with. That's what I suspect we'll find.
We can't really predict the filter condition for the client. We don't know, like when we go in there, it might test out at a 0.9, and we say, oh yeah, let's do it. That might be a clean filter. That might be a washable filter. And if the client puts in anything different later on, it's going to become a problem.
And the guys also recommend putting in a 4-inch filter on those too.
Yeah, absolutely. That's, you know, I mean, all these things you got to evaluate. I always say we can't make decisions based on what might happen in the future. We kind of have to live in the now. But yeah, if you got a client who is not going to do maintenance, and we know that's a lot of our clients, unfortunately, an ECM motor is going to have a problem. If they won't clean their filter, I can guarantee you they're going to get to a point where their static pressure is through the roof, and they could potentially burn that motor up. That's absolutely a problem. I've seen it happen before.
Because the mobile home filters, they've constantly been a problem for us. You know, when we put in anything that's not a washable filter, Ox Air, we see static pressure go through the roof, even with just installing that filter.
Oh yeah, no, I agree. Mobile homes are a problem childs at best.
So I guess this is a question to Matt then. Why do we have to document that on every single mobile home when we've established that this is potentially, you know, 99% of these are not going to work?
We could definitely have a conversation about changing what's in the guidelines. If that's the consensus that there really is not much of an opportunity on mobile homes, we could write mobile homes right out of it.
Some of the mobile home furnace manufacturers even say don't use a polluted filter on their furnace.
Yeah. What do you think, Wade? Do you feel like we should collect a little more data, or do you feel like that really is what we're going to find most of the time on mobile homes?
I am highly convinced that's what we'll find. I would really leave it up to the agencies. If you guys want to evaluate them, go for it. If you don't want to evaluate them, I'm fine with this just making a blanket statement that says you don't have to. I've looked at enough mobile homes. I know what you're going to find. You guys have looked at enough mobile homes. You know what you're going to find. They're just poor candidates because the duct system is so crappy and it's so hard to fix the duct system. So really, you know, my opinion is don't waste your time on it, but it's up to you guys. I know some of you are going to say, oh, well, we want to look at it. We want to see what we can do. That's fine. Go for it. I'm pretty positive that you're going to find over 90% of the time there's not a good opportunity for an ECM in mobile homes.
You guys like that approach? All right, I'll make a note of that, and we'll edit that in our next upcoming edit of the guidelines. But you're welcome to go ahead and do that from this point forward. Any other questions on this?
Hello.
Right.
Hey, so on furnaces with A cabinets, is it just okay just to write it in there as furnace has an A cabinet?
The little 14.5-inch wide dudes that the ECM motors don't fit in?
Yeah.
Yeah, just make a note. It won't fit. That's fine. I get it. You're going to run into those. The ECM motors physically won't fit in those.
Would the model number be note enough? You know, we've trained people to read model numbers and to know what that model number means.
Just cut a hole in the side. They don't have
I'm fine with that. Whatever designation, you know. I mean, just a simple note. Hey, this is a 14-inch wide cabinet. ECM motor won't fit. A picture, whatever. Some people can read model numbers. Some people can't. Whatever works. I mean, I get it. You're going to run into those situations where they won't fit, where they physically won't fit. You're going to run into, if I remember right, it's some of the older ream furnaces that have this really funky motor mounting thing, and the evergreen motors typically won't work in them because of the physical motor mounts. So just a simple note, you know, hey, the thing won't mount in here. I'm all good with that.
Ian, I'm fine if model number indicates that, and you've trained your guys on that. If they make no other note, I don't mind. That's a decision for you as a coordinator, because I can educate myself and look for that when I'm determining whether or not, you know, that was a candidate for an ECM or not. It's really up to you. If, like, I would kind of lean the other way and say I would like my guys to actually make a note and indicate so I can see that they thought about it. But, you know, if your guys are trained and you don't want them to bother with that, the model number would work fine for me. So. Cool. Any other questions or concerns? All I was going to do is go over, and the audit guidelines don't really have a lot on this. I just wanted to point out that we just have a little section on there. It talks about the static pressure, and there's a little more information about where to learn some more about that. So just as an FYI, and just for everybody's info, that, you know, that's my stake in this, is that we want the auditors to be noticing these and evaluating for these when they get to them. And so if you are seeing some of this on a work order, that's what's going on. If you're a technician and you see stuff coming up on a work order, but you can see that the auditor may not clearly understand what's going on, work together to educate one another, and you know, so that we can all get better at this is kind of the goal. So. Anyway, does anybody have anything else before we end? I'll probably just do what I've been doing at the end of all the meetings. If you guys have any suggestions at all for future topics, well, does anybody have any suggestions right now that they'd like to make?
Sure, why don't we talk about balanced systems for ASHRAE?
Ooh, that's a good one.
Balanced ASHRAE.
Balanced ASHRAE.
We're running into kind of both, and we're doing kind of both, you know. So, well, I know we are doing positive pressure, but I'd like to do a little bit of both if it's possible.
Okay.
I think another good one is strategies on keeping a unconditioned basement inside envelope or outside.
Okay. And as you can see, this is kind of my running list. What I've typically been doing is I've been keeping this running list, and then based on, you know, Wade and Dalton and I end up talking, and we try to pick something that seems to be the most pressing from what we're seeing. But if we're skipping over a topic, like you're seeing it on the list, but we're never addressing it, send me an email, and that might help move it to the forefront. So anyway, and then if you have any other ideas, let me know in an email or a phone call or text or whatever works for you. Again, our next meeting will be February the 7th, and we'll determine a topic sometime in the next couple of weeks. Nobody has anything else?
Balance systems would be good because that way we can control more of the air better, rather than just doing it one way or the other.
Yeah, but I came up to brag and saw your positive system. We're working on installing a positive system in the training center as well, and I'm kind of going through that learning process, so I could definitely incorporate the balance system into that, and then we'll probably end up having a training or two in this meeting, and then put out some resources on both of those. So yeah, I think we'll do that soon.
We have a balance system installed in the training house upstairs. It's that Panasonic. The only drawback to that particular Panasonic is it maxes out at 40 CFM. So there are those instances where we need way more CFM. But yeah, those balance systems are awesome. I love them. I think they're way better than exhaust. But they, you run into problems with install and things like that. But
while everybody's on the line, maybe you guys can educate me. Are there other options besides the ERVs and the HRVs? Are there different strategies for a balance system? Or is that pretty much what we're talking about?
You run them through the air handler. There's some that run through the air handler.
And they're balanced? I'll do a little more research. If anybody knows anything, send me some info. But yeah, absolutely. I would love to find a good balanced system, because I feel like right now we have something, for exhaust and something, and I feel like we have a really good approach for exhaust and a good approach for positive. But anyway, yeah, thank you, Lauren. Anything else from anybody? Well, thank you guys for your time. I'll push this video out sometime today in case any of your staff or anybody missed it. And yeah, thanks again, guys. We'll talk to you later.
yep, thanks, guys.
Thank you.
Mm-hmm.